Hi, everyone. Welcome to Math Tutorials 82, where we work together to master the skills that will set you up for success. So, today we're going to be discussing one of the most interesting shapes there are out there, triangles. So, you might be asking yourself, well, what's so interesting about a triangle? So, by the end of this video, you will know exactly why a triangle is one of the most complex, yes, interesting shapes there are out there. So let's start with a triangle. So a triangle is a shape with three sides. You have, in this case, side A, side B, and side C. And so the ancient Greeks, or an ancient Greek called Pythagoras, discovered that for all triangles, or shapes with three sides, there was a relationship between their sides that could be expressed with the following equation. And so you might be asking yourself, well, what equation is this? Well, it's the simple Pythagorean theorem, which states that the squared sum of this side and this side is equal to the squared sum of this side. So one of the theorems is that in this case side A is always smaller than side B plus C. And so I'll show three examples so that we have an idea. So when side B and C are the same length, you have side A plus side B are equal to 10, and side C is 7.07. So in this case, side A is 2.93 less than side B plus side C. So what happens when side B or side C get a little bit bigger, one than the other? Well, let's see. So the next example would be this one where side B gets a little bit bigger than side C. In this case, the sum of these two is 12.5. And so now this side is a little bit less than here. So our first conclusion is that either as B or C get larger, A will remain much smaller than the sum of these two. So this supposition right here is still valid. So let's see what happens when B becomes even larger. So when that happens, side B and C are equal to 15, and side A is equal to 11.18. So we saw that it went from a difference of 2.93 to all the way up here, which would be 3.72. So as side B or side C becomes larger, side A will each time be much less than the sum of B and C. So in this case, if you are walking through a field, you're walking to a field, the shortest distance will always be to walk through the field versus walking around it due to this example we just discussed. So another way to express a triangle is its perimeter. So what's the perimeter? It's the sum of all three sides of a triangle. So in this case, it would be 5 plus 707. So it would be A plus B plus C. And for our first example, it would be 5 plus 7.07. And that would be equal to 7.07. So now knowing that, all the three sides of a triangle actually have a name. So what are these? These are as such. So side A is called the hypotenuse, which is normally the longest of the three sides. When you have an angle, the side that's opposite to the angle is called opposite, and the side that's right next to the angle is called adjacent. So there are many trigonometric functions that were discovered with triangles. Sine, cosine, and tangent. So you might be asking yourself, so what are these relations? So let's start with sine. So sine is basically opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is sine over cosine, or in this case, opposite over adjacent. So you can write it either way. So now there's a demonstration that we will do right now that will show how these all work in tandem, and foremost, how we can arrive to this particular equation, which is going to be one of the most important trigonometric equations that you will see thus far. So if you made it thus far in the video, I'm going to give you 1 gold star. So we're trying to prove that sine squared of theta plus cosine squared of theta equals to 1. And so we have a triangle where we have the hypotenuse, opposite, and adjacent with an angle. So we know that side A, side B, and side C. So we have that the hypotenuse squared is equal to opposite squared plus the adjacent squared. So let's write it out right here. So hypotenuse squared equals opposite squared plus adjacent squared. So what happens when we divide everything by hypotenuse? So we have hypotenuse divided by hypotenuse squared, and that equals opposites over hypotenuse plus squared adjacent, this is squared, hypotenuse squared. So we know this becomes 1. So then we know that opposite over hypotenuse is equal to sine. So we have 1 squared equals sine squared of theta plus cosine squared of theta. Following that relationship. So if you finish seeing the first demonstration, you get 2 stars. So now we're going to perform a demonstration that will show how a triangle can also be used to calculate distances and also set up a coordinate system. So you might be asking yourself, how so? So we're going to demonstrate the following. That if you have your coordinate system where this point is the origin or 0, 0, this system would have an x coordinate of r cosine of theta and a y coordinate system of r sine theta. So if we were to look at this point right here, that point, which we're going to call point B, would be equal to r cosine theta r sine theta. So that will be the demonstration. We'll show why this relationship is valid. So now we're going to try to create a new relationship. So in this case, we're going to multiply sine squared with r squared. So it looks like this. So you might be asking yourself, what's r? So r is what we're going to call this length. So the length of hypotenuse. So how can we do this? So as you know, r squared over r squared is equal to 1. And using the relationship of everything times 1 is equal that same thing times 1. So in this case, what we can do is multiply by r squared the entire equation. So you have r squared sine squared theta plus r squared cosine squared theta equals r squared. And so now you just incorporate it. So you have r sine theta squared plus r cosine theta squared equals r squared. And so this is how we find this relationship. So now we know that based on this and this, that is following the Pythagorean theorem of b squared, well, c squared plus b squared equals a squared. And so this side, we can already say it's r cosine theta. And this side is r sine theta. And this side remains r. So if you finished Seeing the demonstration, you get 3 stars. I hope you've enjoyed the video and you found it very useful, and I guess I will see you in the next one.